2.3, the remainder and factor theorems. First, we're going to review long division. So we're dividing 6x cubed minus 5x squared plus 9x plus 6. We're dividing by 2x minus 1. So first, I just want to represent that as fraction, because that's kind of how we're used to seeing division problems at this point in math. So it turns out that the top number is my dividend and the 2x minus 1 is my divisor. So I know that they are going to be set up like this. And again, this one is my dividend. Just to use some vocab. And divisor. So when we do this, we're really looking at just the 2x part of the 2x minus 1. Okay, we're not looking at the whole thing. So we're comparing the 2x to the 6x cubed, and we're trying to figure out how many times 2x would divide into that. So essentially, we're looking at 6x cubed divided by 2x. So we know that 6 divided by 2 would be 3. If I have x cubed and divide by x, I have an x squared. So now, just like real long division, I am going to multiply this back, write it underneath, and subtract. So 3x squared times 2x would be 6x cubed, which is what we wanted. Then we're going to multiply 3x squared times a minus 1 and have a minus 3x squared. So like I said, just with regular division, we're going to subtract this whole thing. That means I'm subtracting the 6x cubed, and because I'm subtracting the entire thing, I'm going to be changing the sign on this one. So be really careful. That's probably the most common mistake. So negative 5x squared plus 3x squared would be 2x squared, and we bring down our next term, plus 9x. And now we're trying to divide 2x into 2x squared. So remember, that's like 2x squared divided by 2x. It really helps to see it that way. So the 2's would be a common factor, but we have x squared divided by x is just x. And then, and this is a minus 2, isn't it? So because I have that minus, negative 5 is bigger than 3, I would have to have a negative x here. So now once again, we're going to multiply it back. Negative x times 2x is negative 2. Get my marker back. Negative 2x squared. And then negative x times negative 1 is plus x. And again, we are subtracting all of this, so that means we're really adding and subtracting x. So we're basically just changing all of our signs. These are gone. 9 minus x gives us an 8x. So 8x, bring down your 6. 2x would divide into 8x 4 times, so I'm going to write down plus 4. And then we multiply it back. 4 times 2x is 8x. 4 times a 1 is a minus 4. And then again, I'm subtracting all of this. So this will be minus, this will be plus. And we're going to have, let's see, these are gone. 6 plus 4 would be 10. So my answer then, so this is going to be my remainder. And just to complete our math vocab here, my answer from the division problem is the quotient. So my answer in this case is going to be, got to get this adjusted just right so I can see everything, 3x squared minus x plus 4. And my remainder is 10, so it's 10 divided by 2x minus 1. So that's going to be my answer to that problem. So next we're going to look at synthetic division. So synthetic means I'm dividing, but I'm doing that fake thing where I have my little shelf number and I do all my adding and multiplying and stuff. So first I'm going to write this again as a fraction for my division problem. I don't know how it did that. So I have an 8x to the 4th plus 38x cubed plus 5x squared plus 3x plus 3. And I'm dividing by 4x plus 1. Now the problem is I need to use this for linear factors, so that's a note we should make. Can only use synthetic for linear, so I'm good there. 4x plus 1 is a linear factor, but the problem is this 4, right? So I know that if I have a factor that's x minus c, when I do my synthetic division, I put the number c over in there, in the corner there for my shelf number. So the issue is I don't have it in that format. I have a 4x plus 1. X isn't by itself. So what I'm going to have to do is I'm going to have to divide the top and bottom by 4 so that the x will be by itself. So what I will now have is, let's see, 2x to the 4th plus, let's see, 38 divided by 4. Those are both even, so I can simplify and make it 19 halves, x cubed. I know this looks really ugly, but it'll be okay. 5 divided by 4 is 5/4 x squared. 3/4 x plus 3/4. And then my denominator is going to be x plus 1/4. So now that I have it in this format, I can tell I'm going to use negative 1/4 here as my number when I'm dividing. And then my coefficients are kind of yucky. I'm going to have 2, 19 halves, 5/4. It's going to be okay though. 3/4 and 3/4. All right, so I'm going to draw my line. So first I'm going to bring down the 2. 2 times negative 1/4. Let's see, what is 2 times negative 1/4? That would be negative 2/4, which is negative 1/2. So we'll write negative 1/2 here. I'm going to do kind of scratch work all the way around this. 19 halves and negative 1/2 would be 18 halves, right? 19 minus 1 is 18, divided by 2. 18 divided by 2 is just 9. Now I'm going to multiply it back. 9 times 1/4 is negative 9/4. Let's see, negative 9 and 5 would be negative 4/4. And 4/4 is just 1, so this will be a negative 1. Multiply it back. Negative 1 times negative 4 is a positive 1/4. If I add 3/4 and 1/4, I get 4/4, which is another 1, positive 1 this time. 1 times negative 1/4 is a negative 1/4. And if I add them together, 3 and negative 1 is 2/4, which is just 1/2. So I am going to end up with 4 in answer. Let's see, I better go back and check the original problem. I had x to the 4th power. So that means when I start with this 2, it's going to be 2x cubed plus 9x squared. Remember, they're always depressed, so this is 1 power less, minus x plus 1. And my remainder is 1/2. And remember, that's divided by x plus 1/4. So the only issue here is I don't want fractions inside fractions. So I am going to multiply the top and bottom of this times 4. So that is going to give me, let's see, I'm going to keep the quotient part, 2x cubed plus 9x squared minus x plus 1. 1/2 times 4 is just 2. And then my denominator is back to 4x plus 1. And I need to squeeze a plus in there somehow. Let's do this. We'll write really small. So we have plus 1 and then plus that remainder. So this would be my answer here. So this one's about as hard as they get. I thought it would be good to model something that had fractions and something where we had to do a little bit of work before we found that number and we could start dividing. So next I'm looking at the remainder theorem. So the remainder theorem says that if I want to know f of 3, it's the remainder when I divide by x minus 3. So I'm just giving you specific numbers here. And remember, when I'm doing synthetic, it means I put the 3 up here, and then I have my coefficients, and I go from there. So in this case, I'm finding f of 3. So I'm going to put a 3 over here. And my remainder is going to be my answer for f of 3. So when we are doing synthetic division to find a value like this one we call synthetic substitution. And we'll write that at the bottom here in a minute. So I notice on my powers, I have 5th power and then 3rd power. That means I have to have a 0 for my 4th. We have to have that placeholder. Everything else looks good. And again, what I'm really after here is my remainder. My remainder is going to be that answer. So bring down 3, I'm multiplying it, add 0 and 9, multiply. 27 and negative 4 is 23, times 3 is going to be 69, add 72. All right, 72 times 3, so 70 times 3 is 210 and 6, so 216. So that'll be 208, so 208. 200 divided by, or times 3, sorry, is 600, and then 8 times 3, so 624, and so 625 is our remainder. So because our remainder is 625, that means the value of the function when f is 3 is 625. So this is how we would express the answer for that. And when we use, again, we're not trying to divide anything, we're trying to evaluate. That means we're doing synthetic substitution. So your book will always really differentiate between these two. I have a hard time. A lot of times I just call it division. I think we get kind of lazy. Substitution with our vocab sometimes. So I wanted to make sure I pointed that out. Synthetic substitution. So now we're going to look at another theorem. So our last theorem for the day is actually the factor theorem. So this is basically saying like it is a factor if the remainder is a 0. So factor if remainder is 0. Which makes sense, right? If the remainder is 0, that means it divided evenly. So what we're going to do here is we're going to go ahead and use that factor theorem. So basically we're looking for zeros to determine if the binomials are factors, and then we're going to use the ones that are factored to write factored form. So now I'm going to go ahead and try if I have x plus 5. That means I need to try x equals negative 5. So I'll put a negative 5 here. 1, negative 2, negative 13, negative 10. I'm just checking my exponents again. 3, 2, 1, 0. So I know my exponents. I don't have to add any of those 0 placeholders. So we'll go through and work this out. Bring down the 1, multiply, add, multiply. You probably remember doing this last year. Let's see, that's going to be 22, negative 110. Let's see, negative 120. So because I have a remainder here, that means x plus 5 is not a factor. All right, so now we're going to work with x minus 5. So that means my x equals 5. So we'll put a 5 in the corner. Let's see, 1, negative 2, negative 13, negative 10. We'll try it again. We really hope one of them is a factor, otherwise we don't know what to do. Oh, here's our 0. So because the remainder is 0, scroll up a little bit so I have more space. Remainder is 0. That means x minus 5 is a factor. And then this is a depressed equation or a depressed polynomial. It kind of depends on the context. In this one, it's not equal to 0. We're just trying to factor. So I'm going to call it a depressed polynomial. And we're going to use that, and we're going to write out what it is. So if it starts out with x cubed, after I do synthetic, one level of that, I'm down to an x squared plus 3x plus 2. And then we want to go ahead and factor this part. So that'll be x plus 2 times x plus 1. And then I really want to factor the whole thing. So I had an x minus 5 that worked, that was a factor. So I need to include that x minus 5 times the other two that I came up with, the x plus 2 and the x minus, or x plus 1, sorry, for the depressed polynomial. So this whole thing is going to be my answer. So I have to write the complete factorization, not just part of it. All right, this is it for our 2-3 notes.